Chapter 2.4, solving multi-step inequalities. We've been solving inequalities, haven't we?
Yes.
All we've solved are one-step inequalities, though. We've solved using addition, subtraction, multiplication, and division, correct? So today we're just going to have multiple steps to solve our inequality. Still the same processes, though. Still using our inverse operations. There's only 6 sections in Chapter 2, so you guys know what that means. What do we do after we finish a chapter? Chapter 2 test. So we're going to be taking the Chapter 2 test sometime next week. Everyone got it?
Sure.
It'll cover all the stuff that we've learned in Chapter 2.
Are we going to be doing one-step equations on the test, or just it's all going to be?
The Chapter 2 test will probably be all inequalities.
Yeah.
So there'll be some maybe 1 or 2 one-step, and some multi-step ones. Okay? So be ready for the test sometime next week, okay?
Yes, sir.
So let's get into today's notes. Solving multi-step inequalities. There's not a whole lot to write down. There's just a bunch of examples. So let's go through these examples. Very similar to our multi-step equations. We just have inequalities instead of the equal sign. So we're still trying to get the variable by itself. So I have y over negative 6 plus 7 is less than 9. What would be my first step to get y by itself here? Not quite. What do I need to do before that? Now add 6. Now multiply by negative 6. Subtract 7. Very good.
Right.
I'm trying to get the term containing y by itself first, and then I'll focus on getting y by itself. Okay? So I'm subtracting 7 from both sides. What's 9 minus 7? 2.
Snap. 2.
Does my inequality symbol flip or stay the same?
Flip.
Flips.
No, stay the same.
Stay the same.
Which one is it?
It stays the same.
Why does it stay the same? Very good. Remember, we only flip it if we multiply or divide both sides by a negative number. Have we multiplied or divided both sides by a negative yet? No, we've only subtracted a number. So it stays the same. Everyone okay with that?
Yes.
Now, the term containing y is now by itself. So now I can focus on getting y by itself. So now what do I need to do to both sides?
Multiply by negative 6.
Multiply both sides by negative 6. Very good.
Negative 6.
So I have 2 times negative 6, which gives me
Negative 12.
negative 12. Does my inequality symbol flip or stay the same?
Stay the same. Flip.
It flips.
I'm tweaking. It flips.
We multiplied both sides by a negative number, correct?
Yeah.
Anytime we multiply or divide both sides by a negative number, we've got to flip that inequality symbol. So my solution is any number that's greater than negative 12. Everyone got it?
Yeah.
Question? Say that again? Yes, we got to graph it. Tells us to graph each solution, so I've got to graph it.
You got it, dude.
Where is my dot going to be?
I'm negative 12.
Negative 12. Is it going to be open or closed?
Open.
Open. Why is it open?
Because ain't no line.
Very good. There's no line underneath my inequality symbol. It's not greater than or equal to. It's just greater than. So it's telling me that negative 12 is not included in my solution set, correct?
Mm-hmm.
So my solution goes all the way up to negative 12, but negative 12 is not included. Am I shading to the right or to the left?
Little right.
To the right. I want all values that are greater than negative 12, so that's to the right of negative 12. Questions on letter A?
No.
We okay with that?
Yeah.
Not too bad?
Yep.
Can I erase and move to B?
Yeah.
Didn't we do this last year?
No.
You might have seen this last year. Maybe. Okay, 2v minus 4 is greater than or equal to 8. 2v minus 4 is greater than or equal to 8. What do I need to do first?
Add 4 to both sides.
Add 4, very good. So I'm left with 2v on the left. What's 8 plus 4?
12.
12. Does my inequality symbol flip or stay the same?
Stay the same.
Stays the same, very good. Questions with my first step?
Nah.
Okay, what's my last step to get v by itself?
Divide. 2.
Divide by 2 on both sides. 12 divided by 2?
6.
6. Inequality symbol flip or stay the same?
Stay the same.
Stays the same. Questions how I got my solution of v is greater than or equal to 6?
Nope.
Am I moving too fast for anybody?
Nope.
Are we all understanding it?
Yes, sir. 6. 5.
Open or closed dot on 6?
Close.
Closed. And which way am I shading?
Right.
To the right. It's all values greater than or equal to 6. Any questions on B?
Nope.
We okay?
Yep.
Okay. Now let's look at solving inequalities with variables on both sides. So try to remember back whenever we were solving equations with variables on both sides. Did I want to get my variables on one side together first? Or did I want to get my constants on one side together first?
Variable. Constant. Shoot, oh no.
Very.
I forgot.
It is variables. Why do I want to get the variables on one side first?
Because then you can solve even by myself. Or trying to get it by itself.
Yes, but that's not what I'm looking for. You guys remember what would sometimes happen when I would get the variables on one side together?
No.
What would happen with the variables?
No solution.
What happened before I said no solution?
Answer. You would, like.
What happened with the variables?
Oh, they would cancel each other.
They would cancel each other out, right?
Yeah.
Sometimes when I had variables on both sides and I moved one to the other, they would cancel each other completely out on both sides, correct? So I then had to look at the statement that was left over. If it was a false statement, I got what? No solution. If it was a true statement, I got what? Infinitely many solutions. Same concept here. I want to deal with my variables first. If they cancel each other out, then I can look at the statement that's remaining. Okay? So let's deal with our variables first here. What would be my first step if I'm trying to get my variables on the same side?
Add.
Subtract 2x from both sides. Very good.
Y.
So I'm trying to get my variables on the same side as each other. What's 6x minus 2x?
4x.
4x. Does my symbol flip or stay the same?
It stays the same.
Stays the same. Any questions with that first step?
No.
Did my variables cancel each other completely out?
No.
They did not. So I'm just solving it like normal now. Okay? So what's my next step to get x by itself? Add 5 to both sides. What's 11 plus 5?
16.
16. Here, does my symbol flip or stay the same?
16.
Stays the same. And raise your hand if you can give me my last step to solve this inequality.
Me?
Divide 4 on both sides.
Divide by 4 on both sides. Very good. 16 divided by 4.
4.
Symbol flip or stay?
Stay the same.
Stays. So my solution is any number that's less than 4. Questions how I got that?
Graph it?
Does it tell me to graph it?
Nope.
Nope, so I don't have to graph it.
Just have to ask.
Questions on this, or can I move on?
Move on.
Moving along. Okay, letter A. We have 8b minus 3 is greater than 4 times 2b plus 3.
Oh, no.
Raise your hand if you have an idea of what I need to do first here.
Distribute.
Raise your hand. Very good. Distribute. Everyone know how to do distributive property.
Yes.
If I have a number like this 4 being multiplied by a set of parentheses, I can do what's called distribute that 4 through that set of parentheses. So my left side staying the same for right now. And now I'm distributing the 4. So 4 times 2b gives me 8b. And also 4 times 3 gives me
12.
12. Any questions on how we did distributive property there?
No.
Any confusion on it? Okay, I've got a variable on both sides. So do I want to deal with the variables first or the constants? Deal with the variables first. So what's my step here to get the variables to the same side?
Subtract 8 from both sides.
Subtract 8b. What happens when I do that?
They cancel out.
Variables are completely canceled out on both sides, aren't they?
Yeah.
So now I'm just looking at the statement that's left over. What's left on the left-hand side?
-3.
What's left on the right?
8. 12.
12. Does my inequality symbol flip or stay?
Stay.
Stays. So, when we were solving our equations with variables on the same side and we got to this point, this would be no solution. Because -3 does not equal 12, does it?
Nope.
But are we dealing with equations here?
Nope.
No, we're dealing with inequalities.
Yep.
So just because the two numbers are not the same does not automatically mean no solution. I've got to look at what the statement is saying. The statement is telling me -3 is greater than 12.
No.
Is that true or false?
False.
False. -3 is not greater than 12. So if my variables cancel each other out, I get a false statement. What's my answer?
3 is not greater.
No solution. You can use your little no solution symbol, or you can write out no solution. Does that make sense for letter A?
Yeah.
If your variables cancel each other completely out, you get a false statement, you get no solution.
Yeah.
Okay? We still okay?
Yeah.
Letter B. I've got 2 times 5w minus 1 is less than or equal to 7 plus 10w. Raise your hand if you can tell me what I need to do first here. Yes. Distribute. Once again, I'm distributing here. I've got a number times a set of parentheses. So I can multiply my 2 through my set of parentheses. What's 2 times 5w?
10W.
10w. 2 times -1.
2. Negative.
-2. And then everything else stays the same for now.
Yes, sir.
Questions with distributive property?
No, sir.
Am I moving too fast for anyone?
No. No.
Okay. I got a variable on both sides. Do I want to deal with variables first or constants first?
Variable.
Deal with your variables first. How do I get my variables to the same side?
Subtract.
What? Huh? Inverse operations. Very good. Sorry, I couldn't understand you. So what do I need to do in this specific case? Subtract 10w from both sides. Once again, you guys probably saw this coming, but what happens?
They cancel out.
Variables cancel completely out. So I am left with -2 on the left, 7 on the right. What happens to my inequality symbol? Stays the same. Once again, just because they're not the same number does not mean that it's automatically no solution. I need to look at the statement that it's saying. -2 is less than or equal to 7. Is that true or false?
True.
True. What's my answer?
That.
What?
Infinitely.
Infinitely many solutions. I'm okay if you put IMS. Questions on B?
No.
Still okay?
Yup.
Still not too bad?
No.
Any questions about any of the examples we've done?
No.
Okay, that was my last example, but one thing I do want to talk to you about is something we call set builder notation. This is just another way to represent a solution for a problem. So, set builder notation, they have these curly Q braces right here. That denotes what we call a set. A set is just a group of things. So most of the time in math we deal with a group of numbers. So a set of numbers. So, this is how you would read the example. The set of all real numbers x, this bar right here means such that x is less than or equal to 5. The set of all real numbers x, such that x is less than or equal to 5. So in my examples, I could have written it in set builder notation. In this case, I would have said the set of all real numbers x, such that x is less than 4. Like I said, it's just another way to represent a solution. Are there any questions about that? I'll go back to this slide if you wanted to write it down. Just another way to represent a solution.
That just makes everything confusing. Yeah.
Huh?
That just makes everything confusing.
Does it?
It really does.
I'm sorry.
It's okay. I accept your apology.
The set of all real numbers x, such that x is less than or equal to 5.
That's like Shakespeare.
I don't think so.
Would there be another way to put that though?
Say it again.
Would there be another way to say that though? Like,
To read
yeah, I don't,
this.
yeah,
No, this is how it's read right here.
yeah, I don't think it's like Shakespearean.
Can I go ahead and move on to the assignment?
Yeah.
I can come back to this slide if I need to. Here's the assignment, page 83, numbers 4 through 30 evens. That'll be due Wednesday, the 29th on Canvas. I think it's only like 14 problems. And you have 25 minutes to get this knocked out in class. Like I said, a lot of people in my other classes finished it, turned it in. So you have the same opportunity. You got all this time. Use your time wisely, okay? Are there any questions about my notes before I end the recording?